Hello all. In this video we are going to learn about recursive best first search algorithm, which is one of the informed search algorithm. Recursive best first search is a memory efficient version of A star. It uses the same formula as A star, that is f of n is equal to gn plus hn, where gn is a path cost and h of n is a heuristic cost, but it keeps only the current path and one alternative path in the memory. It uses recursion and backtracking with a threshold called f limit to decide when to backtrack. If the current node f of n exceeds the f limit, then RBFS backtracks and explores the alternative path. These are the few points you always have to remember whenever you want to apply RBFS. It keeps tracks of the f value of the best alternative path available. If the current f value exceeds this alternative f value, then backtrack to the alternative path. And upon backtracking, change the f value to the best f value of its children, and re-expansion of this result is thus still possible. So these are the main points to remember. Now let us start the RBFS algorithm with one example so that you will be having better idea. The formula for RBFS is f of n is equal to gn plus hn. Gn cost you all can see along with the ages are given in the graph, and hn cost is given towards the nodes. So you can see for S and T, the cost is not given, h of n is not given, that means it is 0. And you can see for A, the heuristic cost is given besides the node, that is 5. For E, it is given besides the node, that is 7. And the ages implies the path cost. So you can see from S to A, the path cost is 2. Similarly, from S to E, the path cost is 2. So this is how the graph is given, and you have to take the cost from it. So let us start with the RBFS algorithm. As S is not the goal node, we have to expand S node. Expand means we have to check for the child nodes of S. So S is having a child node as A and E. This also will be using a priority queue. So A will be added first, then E, because of the cost. How we have calculated the cost of A? It is similar to A star algorithm. We have used the same formula. Fn is equal to Gn plus Hn. So you can see from S to A, path cost is 2 and heuristic cost of A is 5. So that's why 2 plus 5, cost of A is 7. Similarly, cost of E, how we have calculated? So that is a path cost, that is 2, and the heuristic cost, that is 7. So 2 plus 7 is 9. So A is the best child of S because cost is less. Then as A is the first element under the queue, we have to check for A whether A is a goal or not. As A is not the goal, we will add the child element of A into the queue. So B we have added. So cost of B, how we have calculated? The path cost. So that is S to A to B. The path cost is 2 plus 2 and the heuristic cost of B is 4. So that is 8. So cost of B is 8. Again, we have to check the order under the priority queue. B will be first because cost is 8 and E will be next because cost was 9. Again, we have to check whether B is a goal node or not. B is not the goal node, so we have to expand B and the child element we have to add. So we have added the child element as C. The cost of C we have calculated using the same formula. Fn is equal to Gn plus Hn. So S to A, cost is 2. A to B, the cost is 2. B to C, the path cost is 2. So path cost is 6 plus the heuristic cost is 4. So total cost for C is 10. But over here we have to stop the expansion. Why? Because f limit was 9. So E ka cost was 9, so that was the alternative path and limit was 9. Over here we have expanded the limit because limit was 9 and we have reached up to the cost as 10. That means we have to backtrack. And while backtracking, we have to give the backtracked value to the parent. So that's why at the time of backtracking, it will give the value of C 10 to parent B, then it will give it to parent A. So that's why the cost of A is now 10. So now we will not expand A, we will now expand E because its cost is lesser than the other side. So as E is not the goal, we will check for the child element of E. So E is having child element as F. We have calculated the cost of F like S to E, E to F. Path cost is 2 plus 5, that is 7. And the heuristic cost is 4. So total cost of F is 11. But over here again you can see our limit was 10, which is at the left hand side, and we have reached up to the limit 11. So we cannot expand E further. We have to stop here the expansion because the value of node is greater than the limit. So we'll stop expanding and we will backtrack this 11 value to the parent. So that's why you can see the value of E will become 11 because of backtracking. Its cost is more than A. So we have to expand A now. We will forget expansion of E. So now from A, we will start the expansion. A to B, B to C, we already have done. And the cost was 10, 10, 10. Now we will see whether C is our goal node or not. As C is not the goal node, we will add the child element, which is D. And for D, we have to calculate the cost. Now how we can calculate the cost of D? It is the path cost plus heuristic cost. So path cost you can see 2 plus 2 plus 2 plus 3. So that is the 6 plus 3, that is 9. And heuristic cost is 3. So that's why the total cost of D is 12. But over here again we have expanded the limit. Our limit was 11. We have reached up to 12. So now A, we cannot expand further. We have to do backtracking because we have reached to our limit. So we'll stop expanding. We'll backtrack the F value, which is 12. So the cost of D is 12. So that's why the parent cost C will become 12. Cost of B will become 12. Cost of A will become 12. And we will forget the expansion from A, and cost of A will become 12 because of the backtracking. Now E is the best node to expand because E cost is 11. So from E to F, F to G, we have already reached in the previous loop. So up to G we have already reached. So G is not the goal node, so we have to add the child element of G. So child for G is T. We have to calculate the cost for T. How to calculate the cost of T? It is the path cost plus heuristic cost. So you can see from S to E, E to F, F to G, G to T. The path cost is 2 plus 5, that is 7, 7 plus 2, that is 9, 9 plus 2, that is 11. And for T, the heuristic cost is 0. So that's how we can add. 2 plus 5, that is 7, 7 plus 2, that is 9, 9 plus 2, that is 11, and heuristic cost is 0. So that's why T ka cost is coming as 11. So this is how from S, first we have selected left subtree for the expansion, but because we reached to the limit, we done the backtracking. Then E we have expanded. Then because of again the limit, we again done the backtracking. Again we have reached up to D, but again the cost we expanded, we have done backtracking. And finally from S to T, we have reached up to the goal node with the cost as 11. So that is the recursive best first search algorithm. Over here you have seen it is using the same formula as A star search, but only the thing is number of time it has to do backtracking. That is what the recursion is. So that's about the recursive best first search algorithm. We have reached to our goal with the minimum cost, that is 11. So that's it from my side. Thank you all of you.